All right, so let's begin chapter 5, which is going to start introducing factoring. This is probably the most critical chapter in this course. So you're going to want to really pay attention and maybe watch these videos a couple of times, practice, go into um, the study guide that's in my math lab, as well as the homework, because you're really going to want to master factoring because it's something that we build on going forward. So make sure that you are, putting that time and effort into this chapter because if you don't, you're really going to be suffering the consequences going forward. And I don't say that to scare you. I just want to prepare you for what is going to happen. So please, please, please take my warning seriously. All right, so let's go. All right, so what is factoring? Factoring is basically undoing the multiplication that we did in the previous chapter. So we know that if we have this 3x on the outside here, we can distribute that 3x into the 5x minus 2, and that's going to give us 15x squared minus 6x. Well, in this chapter, what's going to happen is we're going to start with this end result here, and we are going to have to figure out what we multiply together to get this. All right, so we're going to factor out what's called the greatest common factor. So the largest term that divides both of the terms evenly. Okay, so it sort of undoes or reverses the multiplication. Okay, and the point behind this is that at some point in this class, we're going to be graphing quadratics, graphing parabolas. And this form is going to be a lot more efficient for us to be able to graph them and also to figure out some characteristics of those parabolas. So that's really the purpose of why we do this. It's like, well, why did we learn this if we were just going to end up having to put it back to where it belonged anyway? And again, the reason is we are going to figure out exactly where these parabolas, which we've seen before, so they're going to cross the x-axis, and this form will allow us to be able to find out exactly where these parabolas cross the x-axis. It's a very efficient form for us to be able to do that, okay? So it's not like a lesson in torture. There is a purpose behind why we take this perfectly good binomial and we turn it into something that looks like this. So the first step in factoring a polynomial is to find the GCF, the greatest common factor, okay? It is the largest term that is a factor of all of the terms in the polynomial. So it's basically the largest term that divides each and every single term in the polynomial without any sort of remainder, okay? So if we look at this first example here, you have 7k plus 28. So you have two terms. You have the 7k and you have this 28. The largest term that is going to divide evenly into both of these is 7, right? You can divide 7 evenly into this. You can divide 7 evenly into 28. So that's what I'm going to do. So I'm going to divide 7 into both of these just to kind of show you what's going on here, which means 7 is our GCF. All right, so 7 is our GCF. So every single one of these factoring problems is going to have this structure to it. So you're going to have your GCF sort of out here, and then you're going to have parentheses, and you're going to have what I call leftovers from the first term, plus or minus, depending on if this is plus or minus, the leftovers from the second term, plus or minus dot, 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 because if there are 3, 4, 5 terms, it's just going to continue to go on forever and ever, depending on how many terms you have. So this is the structure of what we are going to be seeing here. So we have 7 is our GCF. We know that because it is the largest term that divides our binomial evenly. And when you divide this first term by 7, you're left with just a k. So you're left with a k. And then when you divide the second term by 7, you're left with just of 4, and then the plus sign is just going to come along for the ride. So there is your factored form of 7k plus 28, okay? So again, you're going to figure out what is the biggest term that divides both of my terms evenly without remainder. And again, you can check your answer by distributing this back in. And if you get back to your original results, then that is a pretty good idea that you're doing it correctly. So let's take a look at this one now. So we've got 32m plus 24. And remember, we're looking for the greatest common factor, not just a common factor. So a lot of students look at this and the first thing they think, oh, 2 divides both into both of those, or 4 divides into both of those. But remember, you're looking for the greatest common factor, the largest term that divides evenly into both of these. And the largest term that divides evenly into both of these is 8. So 8 is my GCF, which means I'm going to divide both of these by 8, and I'm going to figure out what my leftovers are. So when you take 32m and you divide it by 8, you get 4m. And when you take 24 and you divide it by 8, you get 3. And you are done. So let's suppose you thought 4 was your GCF. Let me just show you what would happen here. So you have 4 is what you think your GCF is. And you have, that means you're going to have an 8m here plus 6, right? Because again, you thought that 4 was your GCF. So you divided this by 4, you divided this by 4, and that left you with 8m plus 6. Well, one thing that you need to recognize is that these two terms right here still have a common factor of 2, which tells you that 4 was not big enough. These terms that are inside the parentheses in the leftovers have to be what's called relatively prime. Okay, they have to be what's called relatively prime, which means their GCF inside the parentheses has to be 1. If the GCF is any number greater than 1, it means you have more work to do, or you did not pick a GCF that was large enough. All right, so let's take a look at this one. So you've got 8a minus 9, and you're looking at it and you're saying, all right, what can I divide both of these by that's going to divide evenly? And they just don't exist. So these right here, as they stand, are relatively prime already. But one thing that you need to recognize is that if they're relatively prime, it means that their GCF is 1. So you could, again, you could factor out a 1 and say that this is going to be 8a minus 9 left inside here. Now, some of you are like, well, what the heck is the point of that? It didn't do anything, right? It's still the exact same binomial that we have over here, but it just looks worse than it was originally. There is going to be a time when you must factor out a GCF of 1, and it will be in this section when we start factoring by grouping. So just be mindful of that there's some times where you do have to factor out a 1, sometimes you have to factor out a -1, but it does happen where this is necessary. In this problem, not really, you don't have to do that, but there is a time in algebra where, yes, you should be factoring out that 1, which is their GCF. All right, so let's take a look at this one. So again, this one's pretty simple. You've got 5z plus 5. The GCF is pretty clearly 5. And then when you divide each of these by 5, you get a z left there plus 1, and you are done. Because again, if you distributed this back in, you would get right back to your 5z plus 5. Okay, so now we're starting to get into variables that are going to have things in common. So one thing that you want to take a look at is it is always the lowest exponent on common variables. Okay, so it's your lowest exponent on common variables that's going to be part of your GCF. So when you have variables involved, it's usually pretty straightforward. You just look at, all right, I have an x here and I have an x here. Well, I have an x to the 4th and an x to the 3rd. It's always the smallest exponent that's going to be part of the GCF, okay? and then you have to figure out what numbers are involved if you have any at all. So you have 25 and you have 30. So the GCF between 25 and 30 is going to be 5. 5 is the biggest number that divides both 25 and 30. And then again, you look at x to the fourth and x to the third, it's the smallest exponent. So it's going to be this x to the third that's going to be part of that GCF. And what I'll do is I'll show you again what happens when you divide this 5x to the third, 5x to the third. This is where your exponent rules are really going to be critical, right? So when you're now dividing like bases, remember when you divide like bases, you subtract the exponents, and that's going to give you your results. So 25 divided by 5 is 5. X to the fourth divided by x to the third is just x. And then 30 divided by 5 is 6. And then x to the third and x to the third, they just totally cancel out. And that right there is your result of factoring out 5x to the third power, is the GCF. And you can see here that we're probably in good shape because we are relatively prime here. Their GCF is 1 between 5x and 6. All right, so let's take a look at this one now. So these look like they're going to be a lot more complicated because there are more terms and more variables, but if you just follow the process, you should be able to factor out the GCF with almost no struggle at all. So you look at the numbers first, 5, 15, and 20. Between 5, 15, and 20, your GCF is 5. So just piecemeal it together, right? You don't have to figure out what it is all at once. Then you have m to the fourth, m to the fifth, and m to the fourth. It's the smallest exponent, so it's going to be m to the fourth. Over here, you have x to the third, x to the sixth, x to the sixth. Once again, it's going to be the smallest exponent, so x to the third is part of the GCF. So it turns out that your GCF is actually the entire first term, which is pretty neat. And what you're going to do now is, again, divide. And I'm probably going to stop showing this step at this point. You can continue to do this if it makes sense for you, but just in the interest of saving a little bit of time, I'll start to do the division, in my head. Oops. All right. So again, when you divide this whole first term by the GCF, you're left with just a 1 there. So plus, then you have 15 divided by 5 is 3. M to the fifth divided by m to the fourth is just m. X to the sixth divided by x to the third is x to the third. So that middle term is completely done. Bring down the minus. 20 divided by 5 is 4. M to the fourth divided by m to the fourth, they cancel each other out. And then x to the sixth and x to the third is just going to be x to the third. So again, this looked like it was going to be a much more difficult problem to do because there were a couple more variables involved, 3 terms instead of 2. But if you systematically figure out what your GCF is, and then go ahead and divide that GCF into each and every term, you should be able to cancel things out pretty nicely. Okay, so let's do this one now. So again, you look at 100, 50, and 25. 25 is the largest term that divides 100, 50, and 25. And then you have m to the fifth, m to the fourth, m to the third. M to the third is the smallest exponent. So that is my winner as far as the GCF is concerned. And now we're going to divide this 25m to the third into all of these terms, and that will give us 4m squared minus 2m, and then the 25m to the third divided by 25m to the third is just a 1. And there it is. All right, so that is factoring out the GCF in a nutshell. As you practice this, it will definitely get more comfortable. Some of you are probably, feeling pretty good about what you've seen so far, which is great. But this is not really the basis of what is going on. We are going to focus more on factoring quadratics, which is a little bit more, takes a little bit more technique than what we're doing here. Come on, there we go. All right, so again, we're going to factor out the greatest common factor. Remember, so we're looking for the largest term that divides everything evenly. So this right here, as much as you may not like it very much, because everything here is being multiplied, so this is some value, a plus 2, and this is some other value, a minus 3. They're being multiplied together, which means this is a single term here, all right? And then you have the same thing going on here. You have an a plus 2 and an a plus 6, and they're being multiplied, which again will represent some single term if we knew what a was. And you can see that a plus 2 is the same in both of these, okay? So this one takes, again, a little bit more skill to be able to do this, but we're still gonna factor that GCF out. And it's still gonna have that same structure of what we saw before of like GCF, parentheses, leftovers, plus or minus leftovers. So it's still gonna have that same structure to it. So our GCF is definitely this a plus 2, which both of these have in common. So that's gonna be an a plus 2 on the outside. And then what I'm going to do is just put brackets here to separate parentheses versus brackets so you can see what our GCF is. So this is our GCF. And now what's inside here is going to be our leftovers. Okay. So when you take the a plus 2 out, you're left with this a minus 3. So a minus 3 is our leftover from this first term. And now we've got to move on to the second term. So it's a plus because the plus is here. And then when you take the a plus 2 out from the second term, you are left with this a plus 6. And believe it or not, this is done. Yes, you can go ahead and combine like terms if you wanted to, but we are just simply factoring out the GCF so we can complete this problem at this step. Okay, or if you wanted to take it out even further, you could say, all right, this is a plus 2, and then when you combine your like terms here, that's going to leave you with 2a plus 3, and it's still a GCF of 1 here, nothing in common except for 1. Again, a GCF of 1 here, nothing in common except for 1. So it does still follow all the rules. Right, so let's do the same thing again here. So this one, they're trying to really draw your attention in by highlighting what the GCF is in blue, and you can see the same thing here as well. So they're just highlighting the GCF in blue for us. This one is interesting because notice that this is raised to the second power, so that will make this problem a little bit more interesting, okay? So we can pretty clearly see that the GCF is this a plus 5b. Again, they highlighted it for us, so that is not too difficult to find out. So there it is. So there's our GCF, and now we want to write the leftovers. So when you take this a plus 5b out from the first term, because again, this is our first term right here, and you know that because everything here is being multiplied. So our k squared is the leftover once I take this a plus 5b out. So k squared is my leftover there. Plus, again, I take one of these a plus 5b's out because this is to the second power. So if I take one of them out, there's still going to be one there. And that will be m squared and an a plus 5b remaining. Because again, there were 2 of them. I took one of them out, which means there's still one left over here. Okay, and this one will go pretty fast. Again, I have my y minus 1 right there. And what's happening when I take that y minus 1 out from each one of these, I'm left with a y plus 3 minus y plus 4. And if you wanted to, you can combine your like terms and continue from there if you wanted. This is pretty interesting because when you subtract y plus 3 minus y plus 4, the y's will cancel, and you're left with just y minus 1 times negative 1, and you could always distribute that negative 1 back in, which again makes things pretty interesting. All right, so this says let's factor this in 2 ways. So we have learned one very important way, which is to look at the 2 terms that you have, or the 3 terms that you have, 4, however many terms you have, and look to see if you can take out something that they have in common. All right, again, not just something, but the biggest thing that they have in common. So you look at this negative 6r squared plus 5r, and you can see that they have an r in common, and as far as finding the GCF, it's always the smallest exponent, right, of those common variables. So the first way that I'm going to factor this is to take the r out, and that leaves you with negative 6r plus 5. So that one's pretty clear. The second way that they're trying to get you to see is that you don't necessarily have to just factor an r out. You can factor out a negative r if you wanted to. Again, that would be negative 1r. And what that will do for you is it will turn this negative 6 into a positive 6r minus 5. And I know that some of you are probably looking at that and like, all right, well, what's the point? Why would you want to do that? Why would you factor out a negative if you don't have to? Well, there will be a point where you have to. The reason why they're trying to get your mind to think that you can factor out an r and you can factor out a negative r or negative 1r is to show you that you can change what's inside these parentheses as far as the signs are concerned. So over here you have this negative 6r plus 5, but let's suppose at some point in this course you want to have a positive 6r minus 5 inside the parentheses. The way that you're going to have to do that is to factor out a negative value, which will change the sign of the values on the inside. Okay? All right, so sometimes individual terms of a polynomial have a greatest common factor of 1, but it still may be possible to factor the polynomial by using a process called factoring by grouping. Okay, so this is going to be an interesting point in the course where whenever you have a 4-term polynomial, your mind needs to shift to at least try to factor by grouping. Sometimes the 4-term polynomial that you're staring at will have something in common and you'll just take it all out. And sometimes you're going to look at the 4-term polynomial and say, hey, there's nothing I can divide all of these terms into these terms. So there's just nothing I can find. Well, then we're going to use this process called factoring by grouping. And it's pretty much exactly what it sounds like. We group things together and then we see what those groups have in common, and then we factor the GCF out from those groups, and then hopefully you'll see what's going to go on from there. And the one thing that you want to really consider though is before you do any other style of factoring, so right now we're learning this factoring by grouping. Before you do that, you need to think about doing this style of factoring, which is to factor out the GCF. If the terms have something in common, like they do here, like they do here, I don't care how many terms there are, if they have something in common, you should factor that GCF out first and then proceed from there. It is really going to be in your best interest to do that. So again, I don't care how many terms there are, look to see if there's a GCF within those terms. If there is, factor it out. And then if you end up with maybe a 4-term polynomial, then you can attempt to factor by grouping. Because sometimes in algebra, one style of factoring, maybe this style of factoring, will lead to another style of factoring once you end up with this set of parentheses over here. Okay? So let's dive back over here. So we have 1, 2, 3, 4 terms here. So as I promised, if you have a 4-term polynomial, you should get suspicious on factoring by grouping. But before you do that, you want to look to see if all of the terms have something in common. So let's say they were all divisible by 2, or they all had an x or something like that, then we would factor that 2 or that x out before we did anything else. But we can see that, you know, we have 6's here, but no 6's there. I have a P here, but no P there. I have a Q here, but no Q there. I have R's here, but no R's there. So there's nothing in common, okay, between all 4 of the terms. So that's when we're going to switch to this other style of factoring, which is called factoring by grouping. So again, it sounds exactly what it's exactly what it sounds like. We are going to group the first 2 terms, just the first 2. All right, so I'm going to group these first two terms to see what they have in common. And you can see that the first two terms have a 6 in common. So I'm going to take my 6 out, and that's going to leave me with a p minus q inside the parentheses. And then I shift my attention over to the second two terms, and you can see here that they have an r in common. So plus is going to come down for the ride. R in common, so the R comes out, and that leaves you with a P minus Q inside the parentheses. And now this is starting to look exactly like this. Oops, going the wrong way. Sorry about that. This is starting to look exactly like these problems, where you had these sets of parentheses in both of the terms, right? You had an a plus 2 and an a plus 2. You had a y minus 1 and y minus 1, an a plus 5b and a plus 5b. Over here, you have a p minus q and a p minus q. So you have the same stuff in both sets of parentheses here. This ends up being your GCF. So we're going to take that out, this p minus q. And remember, when you take this p minus q out, you have some leftovers. You have a 6 here and an r there. So that's going to be 6 plus r, and that is now completely factored because this has a GCF of 1. This has a GCF of 1. Everything is relatively prime. So we have factored out the GCF completely. Okay, so again, you look at the first set of parentheses or brackets in this case, find out what they have in common, take it out. Go to the second one, find out what they have in common, take it out. And the key is recognizing that you have the exact same stuff in both sets of parentheses. You have the exact same binomial here. You have a p minus q and a p minus q. If that happens, then you can factor by grouping. It doesn't happen all the time. Just because you have a 4-term polynomial does not mean that you're going to be able to factor by grouping. But if it works, great, you've got to do it. If it doesn't work, then sometimes it's just prime and you have to just move on. All right, so let's take a look at this one now. All right, again, you look at these terms and you say, do they have anything in common? X here, no X there. 2, 4, 8, but no 2, no multiple of 2 over there. So the 2 is not going to be able to be factored out. There's a couple of Y's here, but no Y's there. So we're going to be able to try to factor by grouping because we have 1, 2, 3, 4 terms. So again, group the first 2 terms, bam, and you can see that they have a y in common. So I'm going to take that y out, and that leaves you with an x minus 2. Cool. And then over here, I'm going to group the second 2 terms right there, and I'm going to put a plus sign. Notice that I included the negative inside the bracket. It's important to do that, and then just put a plus sign there. So that way it doesn't look like you're multiplying these binomials together. It is important to do that. So include, anytime you have a negative for this third term here, definitely include it inside the bracket. So that way you'll see what to do here. So you have this negative 4x plus 8. And most of you are looking and say, oh, they have a 4 in common, right? So if you take the 4 out, again, the plus side comes down for the ride. Take the 4 out, that's going to leave you with a negative x plus 2. But that's not what we want. We want a positive x minus 2. So you can't just factor out the positive 4. You have to factor out a negative 4. So that way, when you factor that negative 4 out, you're left with positive x and minus 2. Because what we're looking for is the exact same binomial inside both parentheses. Close enough doesn't cut it. They have to be exactly the same. X minus 2, x minus 2. If the signs are not matching up, you need to factor out a negative value. I don't know what happened to my negative. You need to factor out a negative value, not the positive one. Okay, so we're pretty much done with this problem now because we have our GCF. It's going to be x minus 2, and then our leftovers will be whatever we factored out originally, which is a y and a negative 4. So this is now completely factored. And another common question that students ask, and might as well bring it up now at this point, is can I switch the order here? If I wrote this as y minus 4 and then x minus 2, does that matter? No, of course not. Multiplication is commutative, so the order that you put it in does not matter. Now, if you decided to do this, x minus 4 and y minus 2, that is completely wrong. The terms need to go in together in the correct set of parentheses. You can't just arbitrarily move these terms around. You can move this whole set of parentheses to the back or to the front, that doesn't matter, but you cannot change the components of each set of parentheses around. That would change the answer. All right, so factoring by grouping, group terms, collect terms into groups so that each group has a common factor. Factor within the groups, which is what we've done. Factor the entire polynomial, so take a look at the whole piece. If you have the same binomial in both sets of parentheses, then you're going to factor that out. And then always check the factor form by multiplying. I'm pretty confident in what's going on here, so if you are just getting your feet wet with factoring, then you might want to try and do this, especially if you're really good at multiplying binomials. You know, if you're really good at taking a look at these binomials and trying to get back here, you can go ahead and do that. I might as well just show you once. So if I took these binomials, the x minus 2 and the y minus 4, and I multiply these together, I would get xy. If I multiply these together, I would get negative 2y. If I multiply these together, I'd get negative 4x. And if I multiply these two together, I would get positive 8. And you can see that each of these are all the components of the original polynomial that I had. xy, negative 2y, negative 4x, and positive 8. So again, you can check your answer by multiplying those binomials that you got by either using the FOIL method or the box method, whatever you're comfortable with, and you'll get right back to your original poly. Okay. All right, so let's take a look at this one. So this one right here, again, you take a look and you say, all right, do we have anything in common? And of course, the answer is no. So we have 1, 2, 3, 4 terms. So let's see if we can factor by grouping. And again, I want to include that negative in there, and I'm just going to put a little plus sign there so it doesn't look like I'm multiplying these together, because I'm not. So I'm looking at kn plus mn, and they have an n in common. So I'll take that out, and that leaves you with k plus m. Over here, they have what appears to be nothing in common, but remember, I told you before, I said it's sometimes in your best interest to factor out a 1 if their GCF is 1. And in this case, factoring out a 1 is not enough. Factoring out a negative 1 is going to be the key here, because again, both of these are negatives, but I need them both to be positive. So I am going to factor out a negative 1 from here, and that will leave me with positive k plus m. And now we have the exact same binomial in both sets of parentheses. So that will represent my GCF. And I have my leftovers of n minus 1. Whatever you factored out from the original sets of parentheses will be left inside the second set of parentheses. Again, it doesn't matter. It doesn't have to be the second one. It could be the first one. All right, so we'll do one more, and then that will be it for today's or this video, and I will post another one later on today. All right, so let's take a look. So this one is interesting because factoring by grouping will be a fail if you just dive into it. If you just dive into these first two and then the second two, you're not going to get the same stuff in both sets of parentheses, but that doesn't mean that you can't factor by grouping. Sometimes you have to rearrange the terms so that way you can get as much as possible to match up. So like you see over here that you have these y squareds and y squareds and a 10 and a 15. So you want to try and get as much together as you can, and then you can factor by grouping, hopefully, okay? So what I'm going to do is I'm going to rearrange my order here so that this is going to be 10x squared plus 15y squared minus 12x squared minus 18. So I'm just rearranging the order so I can put as much together as I can, okay? Now you can move this x squared over here as well, that wouldn't change anything. Oh, missed the y squared. There it is. So again, you can move this x squared over there if you wanted to. Okay. Sometimes there are multiple ways to rearrange the order and get the same answer. So this is just the one that I'm picking. So we're gonna group these and group these, put my little plus sign there, and figure out what my GCF is from my first set of parentheses. And it's a 5, and they both have a y squared in common. So I take my 5y squared out, and that leaves me with 2x squared plus 3 inside that set of parentheses. And then over here, again, I'm going to get suspicious because I have negatives here, but I have no negatives there, which means I'm definitely going to be factoring out a negative value. So I'm going to factor out a negative. And what is that negative value that I need to factor out? It's going to be -6. And when I factor that -6 out, that leaves me with 2x squared plus 3. And that is perfect because I have the exact same binomial in both sets of parentheses, which means when I factor, I'm going to get this as a result. And there it is. All right, so that is factoring by grouping. It is, again, you look to see if you can factor something out from all of the terms, and if that answer is no, and you have 1, 2, 3, 4 terms that you're staring at, you can group a couple together, group the second set together, and then see if you end up with the same binomial in both sets of parentheses like we did here in all the other examples that we've done. All right, and that's it for today's video.